In this video, what we're going to be doing is finding distances between points on the coordinate plane. Now, take a look. In this case, we're asked to find the distance between these 2 points in the segment there that's indicated. If our distances were, say, horizontal or vertical, then it would be a very simple process. Let's draw a couple in. For example, if I wanted to find the distance between these 2 points that I've just drawn, they're horizontal from each other, so we could simply count the blocks. So we've got 2 blocks away, so it's 2 units, however far this is. If they were vertical from each other, so say between these 2, then again we would just simply count. 1, 2, 3, there's 4 away. So in cases where we have horizontal or vertical distances, we can simply count. But what happens if our points aren't vertical or horizontal? In this case, they're on what we might call a diagonal. I can't count these individual little, it just doesn't work. So we have options. In this first example, I'm going to show you one option, and then in the second one, I'll show you a separate one. In this first case, what we can do is use what we just learned with the Pythagorean Theorem. So let's use these 3 dots that I just conveniently made. If I wanted to find the distance on these 2 diagonal, all right, so we'll draw it in here with, let's use red. Let's say I wanted to find this distance. Okay. Well, again, we're running into the same problem we have here. It's on a diagonal. So what we can do, we'll grab a different color. What we can do is draw in a right triangle. Suddenly, now I've got 2 legs. Here's a hypotenuse. We can simply use the Pythagorean Theorem. So this would have a side length of 2, and this would have a side length of 4. We could plug in the Pythagorean Theorem, and we're off to the races. So let's use that same trick here. So if I were just going to go top to bottom to get these 2 kind of in line, I'd go here. Notice, I drew this line from the top dot down so that it's level with the second one. Now I can simply go from here over. And there we are, a right triangle with the distance we're trying to find as the hypotenuse. In this triangle, we've got a distance of 2. And in this triangle, we have a distance of 1, 2, 3, 4, 5, 6. So one way to find our distances is to use Pythagorean Theorem, in this case, work it out. So I'll take a squared plus b squared, and we'd get c squared, with c in this case being the hypotenuse, so it's also our distance. I'm going to trade back out to a pencil in case we make a mistake. So remember, a and b could be either of the 2 shorter sides, the legs of our triangle. So we'll say 6 squared plus 2 squared is c squared. I know 6 times 6 is 36, and 2 times 2 is 4. Add those together, we get 40. Unfortunately, 40 isn't a perfect square number. Now, if it was 49, we'd be okay, or if it was 36, we'd be okay, but 40 doesn't work. So again, we can either estimate, or better yet, let's use a calculator, because notice we were asked to round our answer to the 10th place. So I'll find the square root of 40. And if we're rounding to the 10th position, here's tenths. We'll go 1 spot over. Looks like we'll round down. So our distance is approximately 6.3 units, whatever the units are. Whether these blocks are representing miles or inches doesn't really matter to us. That's one way. Now let's think about this a minute. What was some of the benefits of using this method? Well, one benefit's very obvious. We can draw in the triangle and simply use Pythagorean Theorem. So one advantage is we already know how to do it. Second advantage is it gives us a great visual representation of what's going on here. We can see very, very quickly that we've got sides of a right triangle. We could test and say, hey, if we got, say, what if suppose we got 5.3 instead? Maybe we typed something wrong. Well, this can't possibly be 5. It has to be greater than 2 and has to be greater than 6. So since we got 6.3, we're probably right. So there are the advantages. What are some of the disadvantages of this method of drawing things out? Well, the first disadvantage is we have to use Pythagorean Theorem. It's kind of a lengthy process, but odds are we're probably going to have to do that regardless. For me, the bigger issue is we have to have the grid. We have to take the time to draw it in. All of these are very time-consuming. We're going to have to do Pythagorean Theorem regardless. But all this drawing, all this counting, it takes a lot of time. There is a better way. Let's use this as an example. So instead of drawing in a right triangle, notice we could draw our right triangle in down here, or we could draw a right triangle in up here, wouldn't matter. Instead of drawing a right triangle, I'm going to do something different, because I don't want to spend all my time drawing and counting. I don't want to do that. Instead, I'm going to find the coordinates for these 2 points. So let's find this first one. It's 5 to the left, so that's -5. And it's 2 down, so -2. So there's its coordinate at -5, -2. Let's find the other coordinate. Well, notice I don't have to go from the origin left or right any, so it's 0. And I go up 1 spot, so 0, 1. Now this method I call the stack and subtract method. Let's write that down. Stack and subtract. Here's how it works. We're going to find the difference between our x's and the difference between our y's. I'll show you what happens. So let's do the first one. How far is it if we were to go, say, on our x-axis here? How far is it from 0 to -5? Right, well, it's 5, right? That was pretty easy. Right. If we were to go from 1 all the way down to -2, how far is that? Well, it's simple. It's 3. These are the sides of our right triangle. Notice, if I go over 5 and up 3, 5, 3, those are the sides of the right triangle. So if we can just use the coordinates and do a little bit of subtraction, we don't have to spend all our time drawing and counting. So a squared plus b squared is c squared. Notice Pythagorean Theorem is going to be in here regardless of which method we use. So I know 5 squared is 25. 3 squared is 9. Add those together, we'll get 34. Oh, not 36. What in the world am I doing? 34. And then to undo that square, we'll simply use the inverse. And again, 34 is awful close to 36, so we know it's going to be a little bit less than 6. So if we take our square root of 34, and again, rounding to the 10th position here, so we got 8, go over and we see it's a 3. So it's about 5.8 units. Again, approximately. So there are the two methods that we'll have at our disposal this year. You can draw the triangle in. Works just fine. A little time consuming all the drawing. Or, instead of doing the drawing, we can just simply find the two coordinates. And we can use the stack and subtract method. So I'm sure a lot of people are looking at this, especially if you're new, and saying, well, why in the world would I use the stack and subtract? If I've got the grid, why can't I just draw it in and do it that way? Again, there's nothing wrong if you've got a grid. Because notice what happens. As we advance on, you'll find that there'll be times when you don't get a coordinate grid. We're simply going to give you the two sets of coordinates, and you've got to find the distance. This is where stack and subtract comes into its own. So let's try this third example. I'm going to go ahead and stack them. And it doesn't matter which one goes on top, which one goes on bottom. I'm just going to rewrite this one below. 8, -7. Now, a lot of people are tempted to draw in the subtraction sign. You'll notice up here I didn't do that. Let me show you why. If I write a subtraction sign here, I'll do it kind of faint. If I write a subtraction sign in here and I told people to take -2 minus 8, I would get the answer of 6. That's what I get from people, even though it's just dead wrong. So here's what I do instead. Don't draw the subtraction problem. Don't draw it out that way. Let's think of it like this. How far is it? If I go from -2 on the number line all the way up to 8, how far would I have to go? Well, I'd have to go 2 from -2 to 0, and then 8 more from 0 to 8. So that's a difference of 10. Still a subtraction problem. And notice I don't get that negative distance. In this case, negative distance doesn't mean anything. We'll do the same thing here. If I'm going from 6 to -7, how far am I going? Well, from 6 to 0 is 6, and then 0 to -7 is another 7. So in this case, it's a distance of 13. Again, negative distance won't mean anything here. So 10 squared plus 13 squared is c squared. And we can do this really fast. These numbers aren't too bad to work with. We'll have 100. we'll have 169. Add those together, we'll get 269. And then all we'll do is take our square root, and we can find our distance very, very quickly. So in this case, square root of 269, there it is, 16.4 for rounding again to the 10th position, units. Now if I can write, there we are. Units is, well, we'll say approximately. See. Now notice, if I hadn't used stack and subtract, let's suppose I had gone back and started drawing. In this case, I would have had to plot both points, draw the line between both points, draw the triangle for both, and that takes a huge amount of time. Stacking and subtracting is a lot easier, a lot cleaner, a lot more efficient. I really recommend that you use this method instead. Let's do one more. Now, just to show you that it doesn't matter which one goes where, I'm going to write this first set of coordinates under the second to show you it doesn't matter. -2 and 1. And again, we're not going to write this as a subtraction problem, even though it's stack and subtract. We're just going to think about distances. How far? So how far is it from -7 to -2? All right, well, there's a difference there, or a distance of 5. All right, well, how about the next one? From 7 to 1. Well, the distance, or the difference, however you'd like to word it, is 6. So 5 squared plus 6 squared is c squared. So 5 times 5, 25. 6 by 6, 36. Add those together, we'll get 61. 61 is awful close to 64, so this will be something a little less than 8. So we'll take the square root of our 61, see what we get. 7.8 roughly. So 7.8 units is approximately the value of c. So, there it is. The two methods for finding distance. You can either use the Pythagorean Theorem, just draw a triangle, or use the stack and subtract method. You'll get there just as well. Now, if you're watching this video and you're not in one of my classes, there is a third option. Now, if you're in my classes, you can still use this third option. The problem is it's kind of lengthy. So let's take a look at it. And we'll use number 2 as our example in this case. So again, if you are in my classes, these are the two that we'll be using this year. If you want to stop the video right now, go ahead and stop it. I'm simply doing this just to show yet a third method. It is a little different. It works. It's sort of a combination of these two methods. All right, so let's get ourselves some extra paper here. All right. It's kind of a marriage of the two. We're going to use Pythagorean Theorem in this method. It's actually just a reworking of the Pythagorean Theorem using this. All right. Now notice, we call this the stack and subtract method. And for lack of a better word, we subtracted our x values. So let's write that out algebraically. And by the way, this is known as the distance formula. So one thing we did was take x1 minus x2. And what that means is I took my first coordinate and subtracted my second coordinate. And then when we got done with that, we squared it. All right. We did the same thing with our y's. We took our first y coordinate and our second y coordinate, subtracted and squared. Then what did we do? Well, we added them together. All right, well, let's add them together. And then we took a square root. All right, well, let's take a square root. This is the distance formula. If you want, instead of drawing or stacking and subtracting, you can use this fun bit of, well, algebra. Plug in your x's and your y's, work through it all. You can understand why I tend not to teach this method, at least not to 8th graders. It's an awful lot to write out. There's a lot of different places where you can make mistakes. I think it's a lot easier if you either just draw it out, or, I think what's even better, is your stack and subtract. You're still doing the same things as what you're seeing here, but it's done in a little bit more of a graphical way. You know, graphical in this case meaning just done out in space, not necessarily graphing in this means. So finding your distances here is what you're doing there. Squaring it, still doing that here. Adding them together, there's the addition, square roots, and the like. Again, you can use this formula if you'd like. I think it's full of a lot of pitfalls. I think this method here, doing the exact same math, I think this is a little bit cleaner. You're less likely to make mistakes than what you're going to do here. All right? But again, 3 different methods. These are the 2 that we'll discuss in class and use on a regular basis. This one's available to you if you so choose. All right? If you have any questions, I'll look forward to seeing you in the mornings.